Good morning. This is the video introducing you to IViewOps. Now, IViewOps videos have been recorded in two series. There is the plant series, where IViewOps is already configured for your plant and you're using it for day-to-day operations, for operations planning, and for maintenance. And then there is the services series. So if you look for IViewOps on YouTube, or you ask for other sources for the videos, you will find that here is the IViewOps plant video 0, which is the introduction to the plant. Then there are other plant videos like video 3, video 4. Video 3 is on operations planning, video 4 is on lab and SCADA communications. And then there are services videos, which is configuring your plant for IViewOps. What is configuring your plant? Well, you're starting from scratch and setting up the plant, which is usually done by an operations consultant or an engineering consultant or a process person who is familiar with IViewOps at your plant. So again, here are the different videos. What I want to introduce you to over here today is the plant series, which is this video, followed by how you run your plant in steady state and dynamic modes, how you set up your dashboard, which is this video 2. Then video 3 covers operations planning, video 4 covers SCADA communications. So let's get back to this video. What you see here is an asset hierarchy in IViewOps. There are virtual assets and there are real assets. And I will take you through this description of the KNSG plant in the US. It's a real plant on which IViewOps is set up. Now, this plant has what we call an enhanced nutrient removal permit. It has a permit of 4 milligrams total nitrogen and 0.3 milligrams total phosphorus. So it has to do a lot more nutrient removal than some other plants in some other locations around the world. So let's look at what is on the screen. Here is the asset hierarchy. Here is the interface where IViewOps is configured. Though as an operator, you'll principally be using the dashboard, which is covered in video number 2, the plant video 2. Now, if you look at the influent over here, there are essentially two influents. So if you scroll over here, since you may not be familiar with IViewOps, if you scroll over here, the different modules are shown here. And you can go down the series. But here's a simple influent, here's a complex influent, and then there are screens, etc. But you can see the same icon over here. So the influent within it has what we call a baseline flow and what we call an actual flow. The baseline flow, the way we set up IViewOps, is it looks back at the last 1 year average of flows and establishes a baseline. Within the baseline flow, you have two child assets. There is the flow and then there is the lab data. I will not go into the details of how we set up the flow for the baseline flow for each particular day of the week, but you can set it up so that you have different flow patterns for different days of the week using the scheduler. The annual average over here that you see is where the lab data come in. And if you study the IViewOps services video 1, it'll go through the details of all the characteristics of your lab data. But what you're principally interested in for operations is the summary, which is TSS, VSS, the inert TSS, BOD ammonia, and possibly at this time in the lab you're interested in some of the data in the main constituents over here. So you can look through this, and if you're interested in more detail, then you look through again the the services video 1. So here you have TSS, VSS, inert TSS. You can choose whether to use this value of inerts in the model. You have your volatile fatty acids, fraction fermentable, soluble and particulate COD, total COD, soluble non-biodegradable COD, the BODs which are computed, the soluble and particulate and total BOD, the ammonia SKN and TKN which you enter, the nitrite and nitrate in your influent, the non-biodegradable components of SKN, orthophosphorus, total phosphorus, the non-biodegradable phosphorus, alkalinity, etc. Okay. And then you have other more detailed components over here. If you wish to enter values of microorganisms in your influent, you can. But as an operator, again, let's get back to what you have to track is mainly this summary. So as you go through it, while it is a complex model which can function for many different purposes in your plant, for management of the plant, for planning, for asset replacement, and for engineering, as an operator, I want to introduce you to a simple set of functionalities that you would be using on a day-to-day basis. Now those are covered again in videos Plant 1, Plant Video 2, Video 3. Now what is the actual flow? The actual flow, the way we set it up for different scenarios is different, but in this case we are using the actual 30-day average flow. The latest 30-day average is being fed into IViewOps to set up the current steady state, and the latest 24 hours feeds into the current dynamic simulation. Now if you have septage and other wastewater coming in, that is fed in here. Within it you'll also see a flow and a lab data, and do not worry too much about whether you have daily lab data on these. We have ways of setting up IViewOps so that you can get your septage strength and feed it in. Then you have, you can just click over here, you have the bar screen, you have a flow splitter here. In this case they can divert very high flows to the lagoon when they choose to. So that's the lagoon diversion, as you can see over here. If I click over here, you have the grid chamber, and within the grid chamber, well, if you had two grid chambers, it would be set up that way. It could be set up as rectangular or circular. Again, if you look at services video 1, you'll see more details of how we set that up. You have a pump station, and within the pump station you have the tank, and you have the individual pumps. Now why does IViewOps depart from a design model and start putting in pieces of equipment? Well, IViewOps is an asset-based model, and it is ultimately managing your plant to the condition and the capacity of your assets. That means that if you had fewer pumps running on a certain day, if a pump station was out of service, or you had only 1 out of 3 pumps or 1 out of 4 pumps running, IViewOps would reflect that for that day of operation. So it does allow you to get to simulating your real-time conditions. So you have each of the pumps, and then the capacity of each of the pumps, which may be an aged capacity. That means if one pump is older than another and its capacity is lower, we tend to update it once a year and get to pretty good values of what the aged capacity is, and that is used as the pump station capacity. So you have your pumps over here. Then the flow goes out here, and if you click on any line, it has a named flow stream. So if you look at this flow stream, it is named raw influent pump station effluent. So when we set up IViewOps, if we go through it, this will be, if I go back here and I click on this line here, this one is raw influent, this one is screen influent, etc. So let's get back over here. Now let me crunch the screen here and let me display the entire plant for you. Now if you have a high resolution monitor, like a monitor with HD resolution 1920 by 1080, you'll be able to see this entire plant easily on one screen. So we were on this pump station effluent. What you see over here is the RAS coming back and mixing with it. Then this plant has the option of feeding in acetic acid over here. So there is a chemical feeder. They are not using this chemical feeder at this time, but there is a chemical feeder. Then they have the option of recycling their nitrates, their internal recycle or nitrate recycle. It can come in and go into the first part of the aeration tank or the activated sludge tank, or it can come in after this cell over here. So this one is within the secondary treatment system. They call it anoxic A, so we have named it anoxic A. And within that you will see that even though we are showing one icon here, there are 3 parallel trains, and you can have different trains in and out of service on different days. We talk about that later on, how SCADA feeds into this and tells you which trains are in operation. Right now this plant has been operating with 2 out of 3 trains in operation. So if you look here, train 1, train 2, train 3, you will see that train 1 is available but it is offline, while train 2 is online and available, and train 3 is also online and available. So this is for the anoxic tank. You go here, you have an anoxic tank B. The dimensions are here. It's 18 feet deep and 32 feet by 50 feet. So you have each of the dimensions. Now, if your plant is in SI units, it would be configured in SI units, essentially in meters. So you get your plant is set up either in SI or US units depending on the location of your plant. But this one was set up in US units, and this is where we toggle and we lock it, whichever units we have to use. Let's keep going. Here's the swing A system, which has diffusers in it, so they can operate the air if they want to. So there is a diffuser system which we will cover in the next bioreactor segment. This is Oxic A, and what's there in Oxic A? Well, there is the same tank system, and you will see that in the tank system they have 2 out of 3 parallel trains in operation. And then you have the diffuser system, and you set up, or we set up the alpha, beta and all as an operator. You don't have to make changes on a day-to-day basis. We set up the type of diffusers, we set up which blower group in the plant is feeding these the air to the activated sludge basin. So again, in IViewOps we do go into details of how your equipment is laid out and what the condition of the equipment is. You have your DO set point controller, and here you will notice a new thing. You will notice that we can link back to a SCADA file or an Excel file generated from SCADA and bring in the DO set point, or you can use a default value. So we will talk about that more in the subsequent videos, but I will show you the attachment and how it links up to another file. And we have an on-off controller if you want to operate your air on and off. I discuss on-off controller of aeration in detail in dynamic simulation. So the IViewOps services series video 2 has on-off controllers. Then you have Oxic B system, which is essentially this one here. Then you have the last third of your aerobic zone, which is the Oxic C system. Then because this is an ENR plant, it has post-anoxic zones where here this is a swing zone. That means that it has diffusers in it. It can be operated aerobically or anoxically. Then you can feed supplemental carbon over here if you choose to. So this is the post-anoxic chemical feed, and you can feed supplemental carbon here. You can also feed a chemical alpha 208, which is used for adding ferric and aluminum to the plant. Here is your nitrate recycle. If I click here, you will see the internal recycle system. But we have done a little bit of a strange thing because of the way the hydraulics of this plant works. Some of the nitrate recycle is pulled out of the beginning of this second anoxic cell, and some of it is pulled out from the end of the second anoxic cell. So if I click on this anoxic cell, it has its 3 trains over here with the dimensions of each. And if I click here on this flow splitter, you will see the nitrate recycle system set up with the flow controller here, which is if we are recycling nitrates from here versus here. In this case, we are recycling all the nitrates from here, but we could set it up that half of it is coming out of here because of the way the hydraulics work, and half of it is coming out of here. Okay, so if I click back here, you will see that this flow is set to 8 mgd for this flow controller. And this flow controller here can take data from your SCADA system. So there is a link up to a file which is fed from SCADA, and that link up is shown here. Now, if I look at this nitrate recycle system again, it has the internal recycle pumps. They call it internal recycle. So the pumps are over here, and the capacity of the pumps are here. So if a pump goes out of service, SCADA can turn this pump out of service, and the plant would operate for the last 24 hours based on the other pumps that are online, and it would show the effect of that. If you keep going down this avenue, over here, there's another chemical feed over here. So they have the option of feeding the alpha 208, which is for chemical precipitation of phosphorus over here. Then you have a reaeration zone, and then what we have done in this plant is we have split the clarifier into a more detailed modeling, because here in this plant they turn the blower on and off. So the stilling well of the clarifier has been split out of the clarifier and shown over here. Then the main body of the clarifier with its sludge blanket is here, and then the clear liquid zone of the clarifier is here. Okay, so let me compress this side so that you can see the entire plant, at least the liquid treatment part of the plant, on one screen. So after the clarifier, there is, oh, well, this was the clear liquid part of the clarifier. Then you have a filter, and the filter backwash is going to get recycled back to the headworks. You have a disinfection unit, and then you have the effluent going out over here. Now, if you follow the underflow of the clarifier, it goes into a waste splitter, like you see over here. And in this plant, they're not using pumps. They use a valve to split the flow, and the waste flow is split only at a certain time of the day in the morning between 8 and 10. So the dynamic simulation sets it up that way, and the RAS is returned over here. So that gets you a picture of the liquid treatment system. Now let's look at the solids handling at this plant. Well, this is a smaller plant, and we will look at a larger plant towards the end of this video. This plant has the WAS going in here. $30,000 gallons per day of WAS going into the aerobic digester. And the aerobic digester is configured in an interesting manner in that they have 4 digesters, but they're operating it in series. So 4 digester tanks operating in series. And within each, you will see the dimensions of each tank, what the depth is, what the length is, etc. We have set it up such that the air cycles on and off in dynamic simulation. Its aeration cycles on and off. The supernate is drawn out of the last of the 4 tanks in series, and the thickened sludge from the bottom, the digested sludge, is pumped out of the last of the 4 digesters in series. Then it goes into a dewatering system, and within the dewatering system we do specify how much solids removal you have and how much is the dewatered sludge flow. So we will talk about that when we set up a dewatering system. But within that, you'll see 2 values. One is of flow controller, which tells you what percent of the overall sludge flow, overall flow into this dewatering system came out in the sludge. And then the other part is what percent of solids capture you have. And the solids that are not captured and the flow that is split off and separated is recycled back through here, back all the way to the headworks. So that in a nutshell covers a plant. Now we talked about having links to other files, and here it is linked to a file called KNSG data feed, but we could also link it to the monthly data. Now here is an example of a monthly data sheet that we could set up when we are setting up your plant to feed the data that is required for IVops right from here, from the monthly into IVops. Or we could set it up to take data from SCADA, or we could have a simpler configuration, which is what we use and which we cover in Plant Video 1, which is a simple file which serves as a feed into IVops. Now as an operator, we make it fairly simple because we understand that an operator at a small plant has to work in the lab, may have to work in a pump station which is away from the plant, and only has a few minutes to look at a computer. So IVops for a plant is set up such that an operator does not have to spend much time on the screen, but can get the data out of the dashboards, which we cover in a later video. Now, as far as how do you get results out of IVops, well, if you click on any flow line in steady state, you will see the characteristics of that flow stream. So you see some of that here. You can also look at some other locations within IVops, but let's first, before we leave this, look at what the TSS and VSS are. Let's say going into the clarifier in winter here in this plant. So this is TSS and VSS going into the clarifier. If I click on a line here, this is what is coming out of the clarifier. So if you look at TSS and VSS here, it's 9.7. Here going in is 4800. And so you can see the ammonia, nitrate, etc. You can also see the results by clicking on the results tab. You can also see results in the dashboard, which we cover in a later video. Here is the operator's dashboard for steady state. You can get summary of values for different flow streams like raw effluent, secondary effluent, ammonia, in each of this, the nitrate in each of these. And then you can also track the operating MCRT without the secondary clarifier here, the MCRT for the aerobic zone. You can add different monitors. You also have a dashboard for dynamic simulation. What I've done is, this dashboard is viewed if you go into this second scenario and then you're on dashboard for the second scenario, you'll get the dashboard for the dynamic simulation. Here is the dashboard for the dynamic simulation. You can see the flow pattern. If you want to see the ammonia pattern over a 24-hour period, if you want to see the nitrate pattern, you can view all that from the dashboard. You can also look at it at different points along the plant. Now this plant cycles the air on and off. That's why you have an ammonia spike at this time, and you have the corresponding nitrate go down in oxic A. So you can view dashboards this way and see how the ammonia, nitrate, or orthophosphorus or any other parameter of interest is trending at different points along the plant over the last 24 hours. You can also go into the results tab, which was here. Go into flow streams, click on any flow stream, and you'll start seeing the graphs of the flow stream. So the ammonia over here, let's keep going down. Let's say the anoxic A effluent, it's ammonia at different times of the day. You want to see the anoxic B effluent, it's ammonia, and keep going down. You want to see, let's say, the anoxic C effluent, which is the post-anoxic zone. You want to see the reaeration effluent ammonia. You want to switch over to the nitrate. Here is the corresponding nitrate. You want to see the secondary effluent. Here it is, the nitrate. So you can track all the results also using the graphs and tables in the results. Now, as far as the scenarios that are set up, If you look here, the current steady state, and if you look at the liquid temperature, this is running at 11 Celsius, mixed liquor temperature. If you look at the evaluate steady state, this is running at 21 Celsius. What we have done here is, in this case, the operator is deciding that he or she wants to run a different condition for evaluation, and so they run it in evaluate steady state. And in plant video 3, we cover how you allow the operator to do that. It's a very important tool for the operator for both operations planning and maintenance planning. Finally, what we cover is what we do for larger plants. For a larger plant, the setup is a little different. It uses IVops 3, where you have certain other additional functionalities like layers and zooms, and you can zoom in into a part of the plant, or you can zoom out, and you can create different views, like a view for the headworks, which is different from a view for the rest of the plant. So if you have a plant, a large plant where different buildings have different computers, and they just want to see certain monitors for the headworks, and some of these are actual monitors and some of these are data coming from IVops. So here you have the headworks, you have the east train, the west train, and solids handling. So you can set up IVops differently in the larger plants using views instead of dashboards. That kind of covers the entire set of introduction for IVops. So if you are more on the operation side, please go through the plant series. If you're also on the services side, providing consulting services, then go through the services series. Thank you.